boy, it's the topic of all topics. We're talking about factoring polynomials where a is greater than 1. Let's review how we factor. So remember, we're going to complete a factor puzzle. We're going to write an expanded form, and again, that is the most important thing that we can do, hence the underlining. Then we're going to group into binomials, factor out any greatest common factor, and rewrite after we factor out that GCF. Now let's go ahead and take a look at example A. Here in example A, you can see that we've got ax squared plus bx plus c, and we're going to factor our expression completely, except this time, a is not 1. So we're going to write down our a, which is going to be 3, our b, which is going to be -2, and our c, which is going to be -8. Now, just like last time, we're going to look for things that can be multiplied to a and c, except this time a is 3, so 3 times -8 is going to give me -24, and things that add to b, which is going to be -2. Now, it's going to be a little bit harder to come up with our factors this time around just because the numbers are bigger, or using multiplication of a is going to be more than just multiplying by 1. So we're looking for things that are multiplying to -2 and add, or multiply to -24 and add to -2. We're getting a negative product, so we know one of our factors has got to be negative and the other one will be positive because negative times a positive will give us a negative. So we've got 1 and 24. No, that's not going to work. 2 and 12, that's not going to work. 6 and 4, now we're on the right track, so we just got to figure out which one's going to be negative. So it's going to be -6, +4, because -6, +4 will add together to give us -2. So let's go ahead and write out our expanded form now. So we're going to have our 3x squared, because again, we're writing it out as we had before, -6x, and plus 4x. Don't forget our c. Our c on the end this time is -8. All right, now we're going to group our polynomials together, or binomials together. So we got 3x squared, -6x, +4x, -8, and we're going to pull out some common factors. So the first one we can pull out, now this is important, we can pull out not just a variable. Before we were able to just pull out x, but this time we can pull out x and a number. So 3 and -6 can both be divided by 3. So we're going to have 3 and x this time that we're going to be pulling on the outside, and that's going to give us 3x divided by 3x squared, or 3x squared divided by 3x is going to leave us just x. -6 divided by 3x is going to give us -2. Now on the other side, we can pull out a 4 this time because we've got an x on only one of our terms. So we've got a 4 that we can pull out here. So 4 on the outside. 4 divided by 4 is 1, or 1x. -8 divided by 4 is going to be -2. And notice that our binomials are the same, so we can see that x minus 2, which lets us know we're on the right path. So we're going to factor out our greatest common factor, which in this case is x minus 2. And we're going to see what's left over. In this case, it's 3x and 4. So our other binomial will be 3x plus 4. There we go. Now let's go ahead and take a look at the next example. Right here in example B, same side of strategy. We've got a is going to be 2, our b is going to be -7, our c is going to be -15. All right, so we're going to multiply a times c, so 2 times -15 is going to give us -30. So that's going to be our AC here, and we're going to be adding to -7. Again, we've got a negative product here, so we know that one of our terms is going to be negative, the other one will be positive. So now we're going to do some factor puzzles here. 1 times 30, no, that's not going to get us there. 2 times 15, no. 6 times 5, no, but close. It's getting closer. 3 and 10. Okay, so 3 and 10, 3 times 10 is 30. So far, so good. And we could add 3 and 10 to get -7. We've got to figure out which one of those is going to be negative. Looks like it's going to be -10, +3, because -10 and +3 will give us -7. Fabulous. Now we're going to write an expanded form. So we've got 2x squared this time. Then we've got -10x and plus 3x. And our c is going to be -15. All right, now it's time to make some binomials. So we've got 2x and -10x and +3x, -15. Let's pull out some common factors. So out of the 2x squared and the -10x, so 2 can be pulled out as our number. So we're going to pull out a 2, and then we're going to pull out an x. So that's going to leave us with 2x divided by 2x squared is going to give us just x. -10x divided by 2x is going to give us -5. All right, on the other side, we've got to pull out a 3 in this case, so we're going to be left with just 3 on the outside. 3 divided by 3 is going to be 1, or 1x. -15 divided by 3 is going to be -5. And we can see that our binomials are the same, so that lets us know that we're on the right track. We're going to pull out our greatest common factor, which is going to be x minus 5 in this case. And then we're left over with 2x and plus 3, so we've got left on the inside of the other one, 2x plus 3. Now let's take a look at the next example. All right, here we go again with ax squared plus bx plus c. Our a is going to be 3, our b is going to be negative 7, and our c is going to be negative 20. All right, we're going to multiply a times c. That's going to give us negative 60. And we're going to try and find things that add to negative 7 here. That's going to be tricky, but we are up to the task. So let's see here. We've got 60 can be 6 and 10. Now that's probably not going to get us there. All right, 6 and 10, that would be 4. No, that's a 1 and 60. No, probably not. Let's see, 50, no. 30 and 2, no, that's not going to get us there. Okay, what else do we got? 5 and 12. 5 and 12, yeah, 5 and 12 will work. We have a negative there, so we know one of our terms is going to be negative, so we just have to figure out which one that's going to be. So we've got 5 and 12. We want to get the bigger one, negative, so we've got negative 12, positive 5. All right, we're going to go ahead now and write an expanded form, so we're going to have 3n. All right, 3n squared minus 12n plus 5n and minus 20. All right, now it's time to form some binomials. So we've got some binomials here, binomial here. We're going to pull things out. In this case, we're going to pull out a 3 and an n. All right, 3n divided by 3n squared, that's going to leave us with just n on the inside. Negative 12 divided by 3n is going to leave us with a negative 4. Fabulous. All right, on the other side, we're going to be pulling out a 4. Nope, pull out a 5 here. So 5 divided by 5 is going to give us 1n. Negative 20 divided by 5 is going to give us negative 4. And we know we're on the right track because our binomials are the same. We've got n minus 4 as one of them, and then left over 3n plus 5 as the other one, and we are done. Now let's take a look at the last example. All right, we've got example D here where we're going to factor the expression 4x squared plus 8x plus 2. But before we begin with just our multiplying, we can see that we have a greatest common factor that can be pulled out of here. Because 4x squared, 8x, and 2 can all be divided by 2. So I'm going to set that aside as my greatest common factor. 4 divided by 2 is 2. You're going to leave me with 2 here for A. 8 divided by 2 is going to give me 4. That's going to leave me 4 for B. And 2 divided by 2 is going to give me 1 for C. All right, so now I'm going to do 2 times 1, which is 2. And I'm going to look for something that multiplies to 2 and adds to 4. All right, so multiplies to 2 is 1 and 2. And that's it. And that's not going to get us to 4. So unfortunately, that means that once we remove that 2, everything else is prime. Now, we're not going to just write prime, though, because we were able to factor out that 2. And since we were able to factor out that 2, that means that 2 is going to go on the outside. We're going to be left with 2x squared, because that's our A, plus 4x, because that's our B, plus 1, because that's our C, once we factored out that 2. So again, we're not going to write prime, because this is not entirely prime. We were able to factor out a 2. That is the difference. If I wasn't able to factor anything out at all, then this would be prime. But I was able to take out that 2, so this is not prime. However, that trinomial cannot be factored any further. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and say thumbs up. If you love this video, go ahead and say sub. And we will catch you in the next one.